This is section 3.3, number 3b, completing the square. So what you'd want to do first is you want to take a look at the x squared term and the x term together. If there is a number that is multiplied by the x squared term, that is the a value. If it's anything other than 1, you have to factor this number out. And you want to group the first two terms together, the x squared and the x term. So it looks like this. Take a 6 out, and you're left with x squared plus, what's 24x divided by 6? Is 4x, right? 6 times 4 is 24, is that right? Okay, so that's great. You want to factor that out. Then what you want to do is you want to complete the square. Remember, inside the brackets, that's the whole goal, is completing the square. So we want to make a space there. 17 is already there, so we include that. And then we also are going to subtract a value as well, so that we're not actually changing the nature of the equation, just how it looks. So that's your first step, okay? Factor the a out of the first two terms, or the x terms, and then complete the square. So let's do that. So what you do is you take a look at the b term, or the middle term here, the x term, that number, you divide it by 2 and then square it. So 4 divided by 2 is 2, squared is 4, right? So 4 goes there. Now, everyone see that? Is that good? Okay, so we've completed in there. Now, by adding a 4 here into the equation, what I've actually done is I've actually added what? I've actually added 6 times 4 by putting that number there. So what that means is I have to, if I've added 24 by putting this 4 here, I have to subtract 24 as well from another part of the equation. So this is what's important right here, the completed square here. So when I rewrite this, it's going to be y equals 6 times x plus half of this number. That's the number that we squared to get this, so it's 2, all squared. And then 17 minus 24 is going to be minus 7. And that should be your answer there for 3b. Okay? So you could graph both of those if you have graphing technology. You could graph them and make sure they're the same. You could also plug in, a given x. You could plug in any x into both equations, and you should get the same y if they're the same. So I'll demonstrate that for you. But let's say we say, well, what if x was 2? Well, if x was 2, then we should find the same y value for both equations that are given if they're the same. So over here, let's use this one we just found. That's 6 times 2 plus 2 squared minus 7. So that's going to be 6 times 4 squared. So 4 squared is 16. 6 times 16 is 76. Minus 7 is 69, I believe. And over here, 6 times, what did I say, 2? 6 times 4 is going to be 24. Plus 24 times 2 is 48, plus 17. So that's going to be 60, 72, plus 17. I feel like something's not quite right here. 17, 72 plus 17, that's going to be 87. So let's see, what did I do here? Did I do something wrong here? 2 plus 2 is 4 squared, 16 times 6, 60. Oh, 6 times, sorry, that is not correct. No one's really paying attention here, I guess. No one's helping me out with my mental math. So 4 squared is 16. What's 6 times 16? I think I did that wrong in my head. What's 6 times 16? 96, okay? 96. So 6 times 16 is 96 minus 7. 96 minus 7 is, that's going to be 89. And of course, this over here is 89 too, so I messed up twice. So 72 plus 17 is 89. There we go. Okay. So, still helpful to have a calculator, even if you're a teacher. All right. So it does check out to be the same number, and so we did this correct. Okay, any questions? Okay.